This is a video for confidence intervals for two proportions. I'm creating a confidence interval for P1 minus P2. In this problem, I'm comparing right-handed and left-handed batting. I get a hit 30 out of 150 times when I go up right-handed. I get a hit 20 out of 120 times when I go up left-handed. It says create a 90% confidence interval to examine the difference. I'm using the same critical values as before, so a Z star, a critical value of 1.645 if I want to be 90% confident. I'm using 1.96 if I want to be 95% confident. I'm using 2.576 if I want to be 99% confident. Every confidence interval has kind of the same setup to it where I have the center. In this case, my center is P1 hat minus P2 hat, plus or minus whatever distribution I'm using, that critical value, multiplied by the standard error. In this problem, I'm being asked to create a 90% confidence interval. So when the time comes, I'm going to be plugging in this value of 90% in for this Z star value. Now, I just want to do a little bit of scratch work before I get into this formula. Let's figure out what my success rates and failure rates look like for both left-handed and right-handed. For right-handed, I was successful 30 out of 150 times. 30 out of 150, I'm typing that into a calculator, and I get 20%. So that means my failure rate with my right hand is 80%, and the number of times I went to bat with the right hand was 150. I'm going to list the same information now for the left hand. Success rate of 20 out of 120. That's 1/6, so 0.166 repeating. My failure rate is going to be 1 minus, and I'm using subscripts of L here to denote left hand and R to denote right hand. When I do 1 minus this number, they're complements, I get 0.833 repeating, or it's 100 out of 120, or 5/6. The number of samples for the left hand was 120. I can choose which way I set up this interval for this next part. I personally like to try to keep the numbers positive, so I'm going to create a confidence interval for the right hand minus the left hand. You could have done left minus right as well. You would just got the same numbers, but negatives of them. For example, 5 minus 2 is 3. If I switch the order of that subtraction, 2 minus 5 is negative 3. It's the same value with an opposite sign. So I'm going to start with sort of my confidence interval formula if I was just looking at right-handed. So I have my P hat plus or minus Z star square root P hat Q hat over N for my right-handed data. When it comes time to compare this to the left hand, I will subtract my success rate for the left. And for spread, the more variables I have, I keep adding that spread. So plus the same sort of setup there for my second group. Now just a note, you should be able to see your old confidence interval formula living in this thing. So if I covered up everything with left hand, that's my old formula of P hat plus or minus Z star square root P hat Q hat over N. If I cover up the stuff with the R, I have P hat plus or minus Z star square root P hat Q hat over N. So again, this is sort of like I'm taking my two confidence interval formulas and I'm shoving them together. So let's fill in the numbers. Success rate for right hand was 20%. Left hand was 1/6. I'm using the critical value of 1.645. I have my success rate for the right hand is 20, failure is 80, number of samples 150. Left hand, I'm doing the same thing, but with that success rate of 1/6, 5/6, and 120. I'll type this into my calculator twice, once with the plus and once with the minus. Just a calculator trick on most calculators. If you hit second enter, that pulls in the last thing that you typed in, and you can just change a minus sign to a plus sign and you should be good to go. So in my calculator, I'm covering up that 20% that I'm typing in, but I have 20% minus 1/6 minus 1.645 square root. I have 20% times 80% over 150. And you notice I'm not going crazy with my parentheses here. I just need to make sure that everything stays underneath the square root. I have my 1/656 over 120. And I get a low value of negative 0.044 or so. I'm going to use that calculator trick where I hit second enter just to show you what that looks like. It pulls in the last thing I typed in, and I can just change this minus sign immediately before that 1.645 to a plus, and now I have the high value of the interval. When I'm trying to make sense out of the conclusion here, you kind of have three scenarios that can happen. So looking at the signs, you could have both of these numbers be a negative. If they're both a negative, this tells you that you're subtracting small minus large number. If I have something like 2 minus 5, that's how I get a negative. So in this example where I end up with a negative, this tells me my results are less than 0. This tells me that my second group is larger than the first. If I end up with an interval that is positive for both the low value and the high value, well, I'll flip that. It's going to be greater than 0 if it's positive, moving the symbol to the other side. This tells you the first group is larger. And when you have negative and positive, I can't tell if the first group is larger or smaller because 0 is inside of my interval. So this tells me that it's possible that the difference is equal to 0. And if the difference is equal to 0, this tells me that the two groups could be equally successful. In other words, the results are inconclusive. Looking at my interval, I'm noticing that I have a negative for the low value and a positive for the high. So I'm in this negative positive situation, which tells me that my results are inconclusive. If my results are inconclusive, that tells me that I do not have statistical evidence to indicate that I'm better at batting with my right-handed versus my left-handed. In fact, I'm not that great at baseball altogether. I have a low success rate for both hands there. If this ended up being a positive 0.044 to a positive 0.111, this would have told me that I'm better with my right hand. How much better? Well, whatever the numbers are. So this positive number says I could be up to 11% better on the right side. This negative number tells me I could be 4% better on my left side. So I'm anywhere between 4% better to 11% worse. 0 is inside of that interval. I cannot tell the difference between the two groups. The results are inconclusive.